In this demo, we'll calibrate a mod flow model using the parameter estimation model PEST and pilot points. Pilot points can be thought of as a 2D scalar dataset. This means that instead of creating a zone and having PEST estimate a single parameter value for the entire zone, parameter values vary within the zone and are interpolated from the pilot points. We'll start with an existing mod flow model. This model isn't calibrated, and we can see the errors by right-clicking on the solution folder and selecting properties. Notice that the root mean squared and the sum of squared weighted errors are very high. We can also see the head differences at each observation point. For this observation point, the difference between the computed head and the observed head is more than 3 feet. This model has already been parameterized and key values have been assigned for hydraulic conductivity and recharge zones. This dialog shows the actual parameter values that have already been set, but GMS can be used to generate these values very easily. For example, we can delete all of the existing values and then click on the Initialize from Model button. GMS will detect all key values defined in the model and add them to the spreadsheet. For now, we will change the values back to what we originally started with. Now we will start the process of creating uniform pilot points across the model area. First, we will create a grid frame and fit it to the active coverage. This ensures that the grid we create has the proper extents. We will set the cell size by creating 5 cells in the X direction and 10 cells in the Y direction. Next, we will convert the newly created grid to 2D scatter points. Now we will edit the scatter dataset and set an initial value of 0.5 for all points. Some of the scatter points outside of the model boundary can be deleted. Scatter points can also be moved around once they are unlocked. The last step in setting up the pilot points is to return to the parameters dialog and associate these points with the HK field. We are now ready to run PEST, the parameter estimation model. While PEST is running, the error and parameter values are shown here in the spreadsheet in the upper right. The plot on the left shows the error. Some of the columns have what seem like random alphanumeric labels. These names were automatically generated and assigned to the pilot points. Once PEST is finished, we can return to the Solution Properties dialog to examine the error summary. Notice that the solution is much improved and the error values are very small. We can also look at the differences between the observed and computed head values at each of the observation points. Notice that the residuals are also very small. In this model, there are 3 pumping wells. For this demo, we'll assume that a pump test was performed at each of these wells and HK estimated. We'll create a pilot point at each well location and enter the estimated HK value for each of these new points. We will then specify these points as fixed pilot points. This instructs the PEST model not to vary the HK values at these points. We'll run PEST again and see how these values affect the results. After the model finishes, we can look at the spreadsheet and see that during the calibration process, the value for the last 3 pilot points did not change. Returning to the parameters dialog, we will now import the optimal values for the PEST run. Looking at the solution properties, we can see that the residuals are very small. We can also display contours of the final hydraulic conductivity field. With GMS, it is easy to calibrate ModFlow models using PEST and pilot points.